This is the demo of UML Parser Grader multi-tenant Saas application, which is deployed on AWS instances. So let's start with the configuration that we have done for AWS. We are using Oregon region, and as you can see here, there are 5 instances currently running, one of which is the front end, that is the UI, which is used for UML parser and grader input and is deployed on one of the EC2 instances. Other 4 instances are the tenants. There are 4 different tenants for this application, and all these 4 tenants are running UML parser program, which is accessed from the front end. Now we have configured a load balancer for all the tenants. So the request to each of the tenant is gone through a load balancer, which is used for balancing the load at the runtime. We have defined certain rules for activating the instances at the runtime. So as we can see here, we have a one load balancer configured for this VPC, and for this load balancer we have 3 different available zones. We have configured a listener for this load balancer, which defines certain rules for all the tenants that are with this load balancer. So as you can see here, so for each tenant we have a specific path given, and with the specific path parameter we are forwarding a request to a specific tenant instance. So this is the general routing that is done through load balancer to the specific tenant instance deployed on EC2. Now we have 4 different auto scaling groups for each tenant. So the auto scaling group defines a scaling strategy given for a tenant. So as we can see here, there is desired minimum 1 instance and maximum 3 instances for scaling each tenant. So let's see the scaling policy applicable. So whenever a CPU utilization goes below 15%, one instance will be removed from the scaling group. And when the CPU utilization goes beyond 40%, one new instance will be spun from the specific tenant group. So likewise, the maximum 3 instances are allowed for our application, and minimum 1 is always there with each tenant. So for each tenant we have the same rule applied, and each auto scaling group is associated with each EC2 instance that is currently running in service. Now we have target groups created with respect to each tenant. So as there are 4 tenants, we have 4 different target groups. Each target group specifies a connection to a load balancer and a auto scaling group. So as you can see here, this target group is associated with our personal project load balancer, and this is also present under the same VPC which is used for other EC2 instances and load balancer and auto scaling groups. So for this target group we have the same instance which is running on 5001 port and with at specific available zone. So for each instance there is port exposed, and that specific port is getting connected with the load balancer. So we have linked this target group with with a scaling group here at the details target group. So the respective auto scaling groups are connected with respective target groups. Now let's see the configuration for VPS, which is the background network for all these instances. So we have used 281 project VPC here, which is the default VPC for this Oregon region, and this VPC has by default 3 subnets given, and each subnet is associated with one available zone. So this is the configuration of our VPC and available zones. So as a front end and a back end, we have deployed and configured EC2 instances with this configuration. And as a database, we are using RDS service from Amazon, and we have used MySQL database under RDC. As you can see here, there is one instance running. So this is a MySQL instance running on DB-T2 micro with the configuration as shown. Other details for this data is the database that we have used, the username and password that we have configured, and the endpoint for at which we can connect to this MySQL database. Now this database is also using the similar VPC that we have used for our front end and back end applications, and it is also multi-AZ. Now let's look at our application. So there is a simple page provided for a grader with some default password. After successful login, a grader can see 4 tenants for which he can upload a code and get a UML parsed, and as well as for each tenant he can provide the grading. Let's start with tenant 1. So let's first provide input as our code to the system to generate the UML diagram. So let's test with test 4. The upload me function will call a tenant 1 from EC2 instance, and the program will execute there to generate a UML diagram, which is shown here. Now this diagram can be graded using the grading functionality. Let's provide the student name. Now the grading system is based on the alphabets here. Comments can also be provided. Once the grading is submitted, the details are saved in the MySQL instance. So let's see the database structure here. As this is a multi-tenant application, we have a single database, data table for all the 4 tenants with respective tenant IDs and the columns representing respective grading fields for each tenant. So as we can see, we have a new record created for tenant 1 here. We are also maintaining separate tables for each tenant. So the first tenant shows the recent record that we have saved from the UI. Let's see tenant 2. So we are here focusing on test 4, and we are testing test 4 for each tenant here. So this is the output from tenant 2, and these are the grading criteria for tenant 2. Let's provide the student ID, the university. Now the grading criteria is different for this tenant, and comment for the UML diagram that is generated. Now at the back end, we can see the new record for tenant 2, and same is stored with the tenant table here. Let's proceed with tenant 3, and the same test data as well. So here is the UML diagram from tenant 3. Let's provide some grading again with the different criteria for tenant 3. And let's fetch record at the back end here for tenant 3. With tenant 4, we perform the same operation. And the output we get from tenant 4, we provide the grading details. Tenant 4 student 5, we have a 5 pointer grading here, and the comments. So we can see the new data at the backend for tenant 4, and we can also see the record in the tenant 4. So this serves as a multi-tenant database for this application. So this is the UI for our multi-tenant, multi-AZ UML parser and grading application. We can also try with some different case, and we get the output here. So this is the general configuration for our multi-tenant, multi-AZ Saas application, and here is the complete demo from starting of UI to the backend application that we have developed deployed on EC2 instances. Thank you.